Good afternoon, everyone. It is my great pleasure and privilege to welcome you all to this presentation and discussion of this very important and timely new book by my old friend, Professor Sunil Mani. The title of the book is India's High-Tech Leap, Industrial Policy and Future of Innovation, recently published by Edward Elgar. Professor Mani is absolutely the right person to have authored a book on this topic, given his lifetime of important research into innovation and policies directed at promoting it. He is currently honorary visiting professor at the Center for Development Studies, Thiruvananthapuram, and also at Ahmedabad University and at the University of Athens. He has held several important positions, including having been the director of the Center for Development Studies, and before that and after the RBI chair professorship and the Planning Commission chair professorship in development economics at the same center. He has also served as faculty and head of graduate studies at the United Nations University Institute for New Technologies, now known as UNU Merit, and has been a visiting professor at Bocconi University in Milan. He has been a member of several important committees, including the Drafting Committee for Technology-Led Innovation Policy, Department of Science and Technology, Government of India, the Advisory Steering Committee, Center for Science, Technology and Innovation Indicators, the Human Science Research Council of the Republic of South Africa, and several others. He has, apart from the current book, he has authored no less than 13 other books and several journal articles and other publications. And as in his long and distinguished career as a teacher, he has mentored many students, including some of the current faculty at the Host Institute, the Institute for Studies in Industrial Development. So what we will do is we will begin with a half-an-hour presentation by Professor Mani on his book, and that will be followed by a discussion first by three very eminent discussants from three different backgrounds, as a topic of this nature deserves different perspectives. I shall introduce the discussants when we begin the discussant session. So they will take about 10 minutes each, and then the remaining time will be open to questions and comments from the audience. So without further delay, let me invite Professor Sunil Mani to begin his presentation on his recent book. Sunil?
Yeah, thank you, Aditya, for the very nice introduction. And I also thank the Institute for Studies in Industrial Development and the represented by its director and Dr. Beena, who has actually organized this event. This book is actually the result of several years of research, some of which I have completed after my retirement. I have now been retired for about 3 years now. And so I have always been interested, as Dr. Aditya Bhattacharya has mentioned, the role of the state in technology development. So this book actually, it takes that idea a little further by looking at 6 high-tech industries which India seems to have been developing. So the way in which I'm going to do this presentation is, can you see my slide?
Yes.
Okay, you can see my slide. Okay. So let me just, okay. So the way in which I'm going to do this is the kind of outline of my book. I'm not going to do a chapter-wise summary of the book and so on. But I just give you an idea of the chapters because there will be people here who would not have seen the book and so on. So just for them, I would give just the chapter outline, etc. But the presentation is not according to the chapters, but according to the issues which are covered, although I will relate them to the specific chapters as well. So first is the core argument and the book structure. And so what role does public policy play in the growth or lack thereof of high-tech industries in a major emerging economy like India? That's basically the central question that I am trying to ask. And the core thesis is that one-size-fits-all approach to industrial policy is very ineffective because what we see is that we have a lot of horizontal policies which are directed at all industries. But what I am arguing is that each high-tech, especially in the context of high-tech industry, each one of them would require a specific vertical policy. And I'll explain that as we go along. So while the horizontal policy is a necessary condition, but for a sufficient growth of these high-tech sectors, you require these vertical policies. So that's basically is the core thesis that I'm seeking to advance through this book. The argument is that sustained growth requires tailored specific strategies, vertical policies that address the unique technological and institutional market conditions of each industry. Because each of these high-tech industries are quite different. And so that's why the technology is different, the institutional background is different, the market conditions for each of those industries are also different. So you require, of course, the very strong enabling environment, which are represented by the horizontal policies, but nevertheless, you require these vertical policies for an optimal growth of these. The methodology that I employ is in-depth empirical case of 6 key sectors, and I'll explain these key sectors as I proceed. Okay. So I've organized this book into 7 chapters. So the first chapter is basically what I'm talking about right now. And then I'll go on to the 6 cases. The first 2 cases are pharmaceutical manufacturing and computer software services. And I'll explain why these were clubbed together and placed in one chapter. Then I look at the R&D and manufacturing of vaccines for COVID-19, which became very important quite recently. Then I have 3, what I may call green industries: wind turbines, solar photovoltaic manufacturing, and electric vehicle manufacturing. And then finally, I conclude and synthesize the findings and offers some policy pathways. So that's how the book is organized. So it's organized into these 7 chapters. Now, the analytical approach is comparative sectoral case studies. And I use the sectoral system of innovation framework of Franco Marabba. So this framework is used in a very implicit manner in all the cases, but not very explicitly by looking at the building blocks of each of those. Normally, in a sectoral system of innovation, you have 4 building blocks. And so I don't distill these 4 building blocks separately in each of the chapters, but what I do is I do it in an implicit manner, and then I put it together at the end of the cases. Now, the rationale for case selection is in chapter 2, as I mentioned before, we have the pharmaceutical manufacturing and software services. So you have a manufacturing and a service industry put here, because these are the 2 established leaders in the industry. They have been in existence for quite some time. Whereas then I have a strategic and emerging sectors, which is EVs, electric vehicles, solar photovoltaics, and wind turbines. Please remember that I'm not looking at the service related to solar or wind. I'm looking at the hardware component of these. Okay, so those are the strategic and emerging sectors, which are very important now. And then, of course, you have a crisis case where actually a crisis has resulted in some innovations, which is actually COVID-19 vaccines. And the data and evidence which is used is basically policy documents and industry reports. I also use a variety of conventional innovation indicators, like, for instance, patent and firm level indicators, and then, of course, secondary academic literature as well. And the objective is essentially to identify the policy capability linkages in each of these the 6 sectors that I've looked at. And it is not a causal econometric analysis. In fact, that would be a kind of a limitation of the study, which I would flag explicitly as I proceed. Now, what would be my claims of contribution of this book to the literature? So it's basically a contribution to the renewed debate which is happening on industrial policy. As you know, beginning with the 1990s, with the Washington Consensus, etc., industrial policy was taken a backseat everywhere, including that of India. But of course, quite recently, what we have seen is that almost every country in the world has been dusting up its industrial policy and state intervention, including that of advanced capitalist countries like the United States, where government intervention or industrial policies was considered to be a dirty word. But you can see that as far as the high-tech industries are concerned, this has been very important. And so there is a renewed debate on industrial policy which is happening. And the book centers on this debate at a critical time in the post-2008 global financial crisis period, and of course the post-COVID-19 pandemic, both of which again highlighted the importance of the role of the state in economic matters, which was sought to be reduced during the economic liberalization phase of the 1990s. And it's challenging the old dogma that it counters the marketing efficiency belief of the 1990s, arguing that decisive state intervention is not just helpful, but it is very necessary. And in fact, what you find is that in a number of countries, you would find specific instances of where the state has been intervening in a very, very explicit manner. And I'll give several examples as we proceed. The first is, of course, the market failure argument, which was very much existence by Arrow and Richard Nelson, etc., in the 1960s, where it is said that as far as technology development is concerned, because high-tech sectors require a fair amount of investments in R&D. In fact, the definition of a high-tech, which is also set out in the first chapter of the book, is that those industries involve much more the embodiment of R&D in the products and services of those industries are much, much higher than other kinds of industries. So private firms, typically underinvestment in high-risk, high-reward R&D because of the failure to appropriate the full returns of their own research. As a result, if private firms are left to invest in R&D, there will always be underinvestment compared to what is socially or what is optimally required, and that would mean bad news as far as the overall economic growth, etc., and so on are concerned. So that's basically the market failure argument, which sort of makes out a case for government intervention, especially in high technology areas. Then, of course, you have the historical precedent. Even in free market champions like the US, you have the DARPA, which is the Defense Advanced Research Projects agency. And in fact, I will give you several examples which, while the United States at one point has said that, it is a very market-oriented economy. In fact, if you look at every single high-tech technologies which they have been developed, because other, people like Mazzucato and so on have also pointed this out very explicitly. For instance, if you take the internet, and if you take the GPS system, and even if you take the mRNA vaccines, which were released during the COVID-19, they've all a result of active state research. And then, of course, the United States has now this CHIPS Act, which is for a brief period, this was underplayed by the current administration, but they have again, put it back on the table as if it were. Essentially to restart a chip, the major research in the area of semiconductor chips and so on. Then, of course, Japan has the Ministry of International Trade and Industry for a very long time. South Korea and China is also now using very strong industrial policies to build their high-tech sectors. Now, you cannot see any single country in the world where government has not played a very important role in terms of promoting the high-tech activity. The actual production may be done by private sector firms, but they have been facilitated in a great way by both through horizontal and vertical policies by the state. So that's a kind of a key insight. This book provides empirical evidence from India which is a leading democracy and an emerging economy, to show how modern state can strategically intervene. In fact, you can see that in all the 6 cases that I have presented, there is state intervention in one way or other. Now, what exactly are the limitations? And I'm flagging this right at the beginning, is that I'm not looking for causal or econometric evaluation of this. In the sense that I take some indicator of innovation or production as a dependent variable, then I have a series of independent variables, and I look at the relationship between these two. This is not what I'm doing. Okay, and because it's extremely difficult, and this is not the way in which innovations can actually be, because if you look at both the system's perspective on innovation, it is basically the result of interaction between the different actors within the system. And this interaction cannot be quantitatively estimated and so on. Sometimes some people have used input-output ways of looking at these things, but this is a very narrow way of looking at what is called the interaction, because the interaction or knowledge flows are both tangible and intangible, and so on. So this is not a causal or econometric evaluation of government intervention that I am looking at as far as these 6 industries are concerned. It's based much more on qualitative and comparative evidence. There are, of course, some measurement constraints, which are quite famous, because in the sense that conventional indicators have their own problems. For instance, if you use patent data for measuring innovation as a proxy for innovation, you know that that has got some well-known limitations, etc., and so on. And it also may understate process and informal innovations which are happening, because in some of these industries, process innovations are extremely important, and that's not covered. Now, analytical gaps which are there is that limited treatment of political economy factors. I have not looked at the state capacity in a great deal and so on. Only in the last chapter, I have made some reference to the state capacity. And also the federal dynamics, because you see, India is a kind of a quasi-federal state. You have the central government, you have the state government, and you have a concurrent list which falls into both, and you have a written constitution and so on. But the center is more powerful than the state, so it's a kind of a quasi-federal state as far as India is concerned. So this federal dynamics is something which I have not gone into the detail. And then, of course, policy capture. It is possible for some of the actors to capture some of these policies and for their benefit. And I'll pick up some of these points later on as I proceed. And there is an uneven depth across these 6 sectors that I've actually looked at, essentially because some of the sectors are very recent, they don't have a very long history, and also secondary source information on them are pretty limited compared to some other sectors. For instance, if you look at also the green industries which have come up quite recently, and many of those sectors are still evolving as we are speaking. So there is a kind of an uneven depth across sectors. And I'm basically flagging these limitations right at the front. Now, why promote high-tech industries in India? Because this question needs to be answered, because India is a developing country which is supposed to be labor surplus, and you have very high inequalities of income and wealth, which has now got accentuated over the years. And very often it is said that why are we focusing so much on high-tech industries as far as a country like India? But here, of course, you can give at least 6 different reasons. And in fact, I would even argue that many of the high-tech industries or products and services are actually used across the country. For instance, mobile phone is a high-tech innovation, but it is used for across the spectrum, and also it is used for say, for instance, because of that you can disperse welfare provisions and so on in a much better way than before and so on. But of course, apart from this, the first one is, of course, the leapfrogging. You can skip resource-intensive stages and move directly to advanced high-value sectors. And that's precisely what is happening. Let's say if you take electric vehicles and solar photovoltaics and in wind turbines. And of course, it's quite varied as far as these industries are concerned. Then, of course, global competitiveness to attract FDI, build cutting-edge capabilities in IT and pharma and semiconductors. Now, we have an explicit semiconductor policy. Semiconductor is not an industry which I have dealt with explicitly in this book, but I have a journal article which is already published in the Science and Public Policy quite recently. And then, of course, there is the job creation, because it creates high-skilled jobs, and because we have been promoting engineering education on a very systematic, very large scale quite recently. And of course, there is a fair amount of educated unemployment also, and so on, and high skill migration has also been taking place. So job creation is creating high skill jobs is one thing which high tech products can actually do, because many of the high tech products, say for instance, if you take a electric vehicle or let's take a mobile phone for instance, where basically it's an assembly of components. So it is not just when you are promoting a mobile phone or an electric vehicle industry, you are not simply promoting that specific industry alone, but you are also promoting a number of components and spare parts which are actually used in these sectors. And it can also leverage India's demographic dividend, which varies across the different states of the country, and so on. Then, of course, strategic self-reliance, and now, of course, recent geopolitical tensions and also the recent war, etc., and so on, have clearly shown that we have to be self-reliant. We have to reduce import dependence in critical areas, especially for defense, energy, and health areas. And so that's also another area, a reason as to why these high-tech sectors needs to be promoted. Then, of course, sustainability, it's promoting green technologies, renewables and EVs. Now, renewables have become extremely important. For instance, now we are having a real problem with the fossil fuels, apart from the net zero emissions targets which we have to fulfill. But again, this recent war has actually shown that if you are completely dependent on fossil fuels, there can be real problems. And renewables and EVs to meet climate goals, for instance. And then, of course, national security, strengthening autonomy in aerospace, defense, and cybersecurity. So for all these reasons, high-tech technology sectors needs to be promoted. Now, if you look at India's high-tech landscape, this is also covered in the first chapter. Which IT sector is concentrated by a kind of a truncated structure with strong performance concentrated in limited set of industries. It's highly concentrated. You have two broad things. One is high-tech manufacturing, and then, of course, high-tech services. The high-tech manufacturing is very largely dominated by, say, for instance, the pharmaceutical industry, if you take the share of value added from the national accounts. Okay. And other segments such as electronics, aerospace remain small but are gradually expanding. So you have the high-tech sector very heavily skewed in terms of the pharmaceutical industry as far as manufacturing is concerned. And within high-tech services, it is basically dominated by the computer software services, where India has emerged as a global leader in this exports of computer software services in 2005 and has been maintaining that leadership share ever since. And of course, the emergence of AI is likely to threaten it in the future, but at least in the short term, this is not going to be the case. We will continue to remain as a kind of a leader in high-tech services. And the key insight is that there is a narrow innovation base. The two sectors that together account for nearly 98% of the patents granted, if you use patent as a measure of innovation, it is very largely concentrated in two sectors, which is basically the pharmaceutical manufacturing sector and the computer software services sector. Now, the case studies, I give an overview. As I said, there are these 6 case studies of 5 manufacturing and 1 service industry. And the case studies can be grouped into, as I said, in 3 groups. The first is the established leaders, which is covered by chapter 2, for instance. 2 globally competitive sectors illustrate different distinct pathways to technology capability and export success. Okay, so let's take, for instance, the drivers of success. This is pretty well known as far as the pharmaceutical industry is concerned. Sudip Chaudhary's work and several other colleagues have actually looked at this aspect quite systematically. And it has been built on the pre-TRIPS process patent regime, the no product patent regime, which prevailed during the period from 1970 to 2005. There has also been a very strong policy support for R&D during this period, and even during the post-2005 period, because all the tax incentives which have been available have been basically, because this is the particular industry which has been accounting for a large proportion of the industrial R&D in the country. And it's a strategic focus on generic drug manufacturing, which is basically manufacturing drugs which are off patents. and using a different process because processes could not be patented. So this has really given a kind of and India has considered to be a kind of a world's pharmacy for a very long period of time, and it continues even now. Okay, and it is characterized by very high level of high R&D density. And so the particular vertical policy which has really helped this industry is basically the patent policy. And of course, further supplemented by the horizontal policy like the R&D policy and so on. Okay. And so that's the story about the pharmaceutical industry, which is pretty well known and well documented. The next one is the software services. India has emerged as a global outsourcing hub driven by a skilled, very high skilled and cost competitive workforce. And there has been also agglomeration effects because this industry is very clustered. It is clustered in various clusters within the country. And the institutional support has from industry bodies such as NASSCOM. And the state has also played a very important role because if you look at the key factor input which has been required for this industry is the skilled manpower, which has come up from universities which are publicly funded. And it's only quite recently that these private universities and private engineering colleges have come on the stream. And large number of these engineers have actually come up from public universities. And also a fair amount of infrastructure support was provided by the state in the form of technoparks and so on, or software technology parks, STPs, and so on, and so on. So the state has played an important role in supplementing the role played by the private sector as far as software services are concerned. And the innovation pattern in pharmaceuticals is innovations led primarily by domestic firms. Because if you look at the pharmaceutical industry, all the major firms have been very serious in-house R&D units. And as I said, the average R&D intensity, R&D expenditure divided by sales is about 5.5%, which is significantly higher than the average for Indian industries as a whole. Okay, although it is much less than what Western multinational pharmaceutical companies would spend, but it is much less. And of course, given the fact that Indian pharmaceutical industry is a generic drug industry, it is basically making off-patent patented drugs for which patents have already been expired, so using the patent data may not be a very good indicator for measuring their innovation. So instead, what you can do is you can use this ANDAs, which is abbreviated new drug applications filings in the US, because the US is the major market for generic drugs, and India's exports are largely to the United States as far as generic drugs are concerned. And so in order to market generic drugs in the US, you have to have what is called an abbreviated new drug application, which is basically you have to do various kinds of truncated tests, which you have to do and by the US Food and Drug Administration. And so the number of ANDAs which Indian companies have secured can be used as a kind of a nice proxy for their incremental innovation in terms of making these generic drugs using their own processes. So the products are known, but the processes are completely innovated by the Indian companies, so they are able to sell them at a much cheaper rate and so on there. Okay. So if you look at the data, then what you find is that more than 50% of the ANDAs which are issued by the US Food and Drug Administration even now has gone to Indian pharmaceutical companies. And as far as software services are concerned, innovation activity within the country is actually largely done by MNCs. You have a number of affiliates of MNCs which are actually operating from India and generating, and now, of course, you have the global capability centers which have come up, but that's quite recent. I'm not referring to the GCCs here. I'm referring to affiliates of companies like IBM, Texas Instruments, and so on, which have been here for a long time and which have actually been doing a fair amount of innovations and so on. But there is a gradual rise of innovations by established Indian companies like TCS, Infosys, and Wipro, and so on, which has been happening, but it is largely still dominated by multinational companies. Whereas in the pharmaceutical case, it is largely by domestic Indian pharmaceutical companies and so on. Okay. Now, the innovation paradox here is that while there is a strong global competitiveness, does not uniformly translate into domestic ownership of frontier innovation across sectors. Because in the case of the both the pharmaceutical industry and the computer software services industry continues to be highly competitive. But in the case of the pharmaceutical industry, it is completely domestically owned, whereas in the case of the software services, it is largely owned by affiliates of multinationals which are operating from this country. So the key lesson is multiple innovation and IP regimes can underpin global leadership, but they can generate divergent paths for domestic capability formation. So that's basically the kind of thing that the results that I get from my analysis of these two sectors. Then I move on to the COVID-19 vaccines, which, as I said, is a crisis-induced innovation which has happened. And here I compare the Indian situation with that of the United States. And of course, immediately the question will be asked, why am I comparing India with US? Because the two are institutionally very different sort of countries. But it is basically an analytical and not a normative countries, because it identifies policy mechanisms which are used by both countries, because you find very similar kind of policies which are used. It highlights the importance of early stage, large scale public investment, because if you look at the vaccine industry, India had a very long history of vaccine making. In fact, it predates even the independence period. We had started making vaccines even from the 19th century onwards, and even the private sector's entry into vaccine making was also very old. In fact, one of the first private sector companies was set up in 1953 itself, okay, for vaccine making. And it emphasizes state capacity in crisis response, because in both countries, what you find is a quick, the state has intervened in different ways. And the lesson is the policy timing and scale matters, not institutional replication. You may have an intervention, but if the quality of that intervention is what matters. So if you look at, compare the two between United States and India, so it's basically not a normative comparison, as I said, it's basically much more analytical. So I take basically 4 instruments of support. So if you look at basic R&D, as far as the United States is concerned, there is a strong federal funding through the National Institute of Health. And let me explain that a little further. Because if you look at COVID-19, the viral genome sequence for SARS-CoV-2, which is the virus which causes COVID-19, was released by the Chinese scientists in January of 2020. But the first vaccine came in December of 2000. Emergency use authorization for the first set of vaccines was given in December of 2020, within a matter of very, very short period of time. And that too, it was an absolutely innovative kind of vaccine, which is what is called the messenger RNA type of vaccines. And so how is that the companies in the United States were able to come out with vaccines which were because vaccine making is much more complex, I believe, compared to normal pharmaceuticals, because these are large molecules and which are very difficult to arrive at new innovations, etc., and so on. Okay. But how is that in the United States they were able to do it? Because essentially, because the United States was working on messenger RNA vaccines for a very long period of time. In fact, they started this research way back in the 1980s. What I mean is the basic R&D for doing this. What happened in the 1980s, and they continued this. When the SARS-CoV-1 came up in the early 1990s, they actually tried to do, in the 2000s, for instance, they tried to tweak this mRNA vaccines for SARS-CoV-1. And so CoV-2 came. Already the fair amount of that, the strong fundamental research was already going on. So the applied development work or tweaking that for the particular purpose became very easy. Whereas in India, what you find is that there is very weak basic research in R&D. In fact, there is very little R&D in fact in vaccines itself. But basic research was very limited. So that's one of the reasons as to why that was difficult. that the institutional support, if you look at big difference between the two countries, in the United States, referred to the COVID-19 as a kind of a war, and then of course you have this Operation Warp Speed. On a war footing, they try to do this. In India, of course, you have a reactive mission in the form of this NECVAC, which is the National Expert Group on Vaccine Development. And then of course you have vaccine administration and so on. And then of course the financial support very limited, quite substantial in the US, very limited in India. And IP strategy, in the United States, the companies were offering patent pledges. Of course, I can come back to that in discussion, and also the Bayh-Dole Act. I can come back to the details of that and so on. India was waiting for a WTO waiver, which of course has not happened. And then, of course, it has been asking for voluntary licensing, which has happened. So the Covishield, which we're making, was based on a voluntary licensing from Oxford AstraZeneca to the Serum Institute of India, which is the largest vaccine manufacturer. So you can see that the state intervention in both countries very differed in terms of quality. Both have used industrial policy instruments, but in a very qualitative way. So here is a country which is supposed to be very highly market oriented, but using every single instrument which the textbooks would specify as far as industrial policy is concerned. I'm referring to the US in this case. And as a result, they have been able to come out with very successful, innovative vaccines, whereas in the India case, we have used them very hesitatingly and in a very piecemeal basis. Okay. So although we have considerable amount of capability in vaccine R&D and manufacturing, but because of our hesitation and qualitative difference in the use of those instruments, the results are quite different. Then I go into the renewable energy chapters, which are basically the solar photovoltaics and wind turbines. And in the book, wind turbines is first discussed, and then solar photovoltaics. Both industries have now become extremely important. The analytical focus here is basically examining the role of the state in building domestic technology capabilities, because the state has, these are new industries where, very high tech, and the state has played a very important role both in the supply side as well as in the demand side, and I'll go into the details of that. And it is grounded in the SSI framework, the Sectoral System of Innovation framework, which I've been implicitly using. And the core question is to what extent India has moved from assembly-based activities into manufacturing-led capability development. Because in both these high-tech sectors, we have moved it India has entered at a much later stage. And so that has got its own problems. And so have we moved away from being just an assembly-based activity to actually manufacturing-led capability development? Another industry which is not covered in my book, but which other people have covered is, I myself also have covered in papers, is basically the mobile industry. Okay, are we having a mobile manufacturing industry or a mobile assembling industry? This is the question that we need to ask. The central idea is the state as a market creator, as far as this renewable energy is concerned, has actively created markets for renewable energy rather than merely regulating them. Okay, so if you look at instruments like renewable purchase obligations, it mandates demand for renewable power. Of course, the actual application of this at the ground level has been very limited. For instance, the generation and discoms were supposed to purchase some 25% of their total purchases were supposed to be from renewable energy, and progressively it's supposed to go up to I think by about 40% by year 2030. But in actuality, this is much less. But at least this industrial policy instrument is there in terms of renewable purchase obligations. Then, of course, you have the National Solar Mission, which provides long-term policy direction and targets. And as far as wind is concerned, you have this accelerated depreciation. AD stands for accelerated depreciation, and GBI stands for generation-based incentives, which are basically instruments to reduce financial risk and improve investor returns. Then, of course, you have the Solar Energy Corporation of India auctions, which enable transparent price discovery and stable procurement. And the outcome was a large domestic demand creation, enabling firm entry and capacity expansion. And in fact, if you look at the manufacturing of these both wind turbines as well as solar photovoltaics, you find large number of firms. Okay, so a market for the key insight is the market for new technologies are policy driven, not naturally occurring. They don't occur naturally. You have to create them through the markets have to be created through active state intervention. So in India, we see that the state has actually actively intervened, but of course, in actuality, India's labor market is not purely policy created; it's policy enabled, but institutionally constrained. And I'll talk about that a little later itself. Now, if you look at the industrial policy instruments which have been used, both solar and wind, you can see a wide variety of policy instruments, some which are very specific to solar, some which are very specific to wind turbines. And then we have cross-cutting policies like the SEZ, industrial parks, and green open access rules of 2022, etc., and so on, which are actually cross-cutting for both, and so on. Now, if you look at the impact of industrial policies, I start with wind turbines because that is covered in the book first. And then, of course, I look at solar photovoltaics. My overall assessment of technology capability here, based on both standard indicators as well as with looking at the actual amount of data, which is technologies which have actually been created. India has developed domestic OEMs such as, I can give the names of two companies, Suzlon Energy and Inox wind turbines, but you have the industry dominated also by affiliates of multinational companies. Okay, and of course, Suzlon has a very large share. Okay, but you have a local supply chain exists for some key components, including blades, towers, gearboxes, etc., and so on. Firms have successfully created adaptations tailored to Indian wind regimes because this technology is very location specific compared to solar, because we have low wind speeds here compared to other countries. Say, for instance, Western Europe and so on, where the wind speeds are very low, and specific site conditions are also very different here. So the technology which is brought out from abroad will have to be tailored to the Indian situation. So these domestic firms seems to have successfully engineered that. And earlier policy instruments, notably the accelerated depreciation and the generation-based incentives, helped to create a stable and predictable domestic markets. But so that's the kind of relatively speaking, a kind of a success story, that you have a wind turbine industry where you have fair amount of competence in designing and manufacturing those blades, turbines, and some of these local companies like Suzlon, for instance, have become very important. But there are two important caveats. One is the incomplete ecosystem for critical components. So it is not a fully self-reliant ecosystem that has evolved. And high-value critical components, we still rely on global suppliers, including advanced control systems, high-end bearings, and power electronics. And this, I'll talk about this power electronics part again later on when I talk about electric vehicles. So that's something which is what I'm trying to say. So for critical components, we still are depending on imports from abroad. Okay. And then localization of R&D did not arise primarily from mandated policy requirements. And it has basically happened essentially because of the market size of the large domestic market justified local engineering. And you find that Suzlon, for instance, because it had, to begin with, this company had a very large, it's almost like a monopolist as far as this industry was concerned for quite some time, till the multinationals entered the fray. And then, of course, the need for site-specific engineering, which, and as I mentioned, those unique wind conditions demanded local solutions and so on. So the localization of R&D did not come from, from some specific government policy, but it has been dictated basically by the market itself. And competitive pressures firms had to adopt to win bids and serve customers. So they had to, and that competition actually enabled them to invest in R&D, become much more low cost, and win.
Sunil, could I request you to skip some of the details?
Okay. So now, if you look at the impact of industrial policies on domestic technological capability building in solar PVs, what you find is that I will skip the thing. There is very high dependence on. We have a very big solar module manufacturing industry here, Now, whether it's called manufacturing or assembling is what I'm trying to say. For instance, if you look at you have almost like 80 firms which are assembling these modules. But if you look at the key components, the polysilicons, wafers, and equipments, all these are imported from abroad. Almost very large things are imported from abroad. And much of the capability is process adaptation rather than frontier innovation. So the conclusion that deep technological capability in upstream high-value segments remains limited is valid. But there are two important qualifications. The production-linked incentive scheme is explicitly trying to change this, and there is sort of integrated manufacturing, which is polysilicon, then to wafer, and then cell, and then modules. This is a kind of a supply chain for the modules. Modules is the final thing that you see on rooftops and other things and so on. Okay, and is now being incentivized. And some large PV module manufacturers are moving upstream. But this capacity creation has not resulted in any technological leadership. Technology dependence is strong. And the reason for this is partly also because it is structural, not just a policy failure. Because solar PV is highly globalized. One country alone in the world is accounting for almost like 80% of that. China is accounting for almost like 80% of this. And it is scale-intensive industry dominated by China. And because of the late entry combined with because the price of these cells have been declining very rapidly. It's almost like an L-shaped curve. If you take the price on the horizontal, on the vertical axis and years on the y-axis, the horizontal axis, it's kind of an L-shaped curve as far as the price of this. So what you find is that firms find it easier to borrow, import these cells and then assemble them into modules and sell them here. Okay. So as far as solar PV versus wind is concerned, solar is modular, standardized, globally fragmented. Production is codified and supply chains are global. Entry via assembly and deployment, learning is relatively very shallow. Wind turbines in the site-specific and engineering intensive requires continuous design adaptation. Strong design and deployment feedback loops are happening here. Learning is deep and cumulative. So the key insight is that solar rapid diffusion, there is rapid diffusion of solar modules, but limited technological mastery. We are still highly dependent abroad. Wind, we have slower diffusion, but much deeper capability formation compared to solar. In absolute sense, it may not be correct. Similar kind of thing for EVs. EVs, if you look at the EVs, for want of time, I will just go into the, I won't go into the phases and so on. If I go into the final point about EVs, what you find is that if you look at the critical dependencies on where you have very high, the part is very high important, but we have very low technological capability. Now, the example of this is because EVs, the key technology is battery cells and semiconductors, which are used for power electronics. That's the 40 to 50% of the cost of electric vehicle is basically the battery. Okay, so there we have a very highest strategic vulnerability, and we have very limited battery manufacturing, which is taking place here, because most of the batteries which are used in the EVs are lithium-ion batteries. And the critical raw materials for making this lithium-ion batteries, which is lithium, nickel, and cobalt, we have very, very short in supply. So we have to import these from abroad. And then, of course, if you look at the power electronics, what you find is that in power electronics, the most important thing is silicon carbide wafers, which is a semiconductor product. Okay, and this, even in the semiconductor industry that we are actually setting up, till quite recently, we didn't have any firms which are actually making silicon carbide wafers. Now, of course, there is one which I just realized that there is one which is just the foundation stone for that has been laid in Odisha quite, I think, a few months ago. Okay. So by and large, we are having an industry which is basically depending on imports for key technologies. Okay, and so the key lessons from the chapters is that sector specificity matters. Pharma is IP-driven success differs from software talent-driven model. Policies must be tailored. The IP policy really helped pharma to catch up. And in the case of software, it is basically the talent, the fact that we have high-skilled, low-cost, high-skilled human resource which is available. The import dependency trap, success in assembly. We are very good in solar, wind, and EVs, hides critical vulnerability in core components and materials. And especially from China, we are still doing that, although we are trying to reduce this and so on. Okay, and even in the case of the critical materials, we do have a four-pronged strategy. I can come back to that in discussions later, but this is all quite recent. Okay, so we need for a coordinative governance. We lack the kind of powerful coordinating agency like Japan's Ministry of International Trade and Industry that drove the Northeast Asian miracle. I use the term Northeast, which of course slightly different from people tend to use East Asian miracle. Policy is often fragmented here. R&D investments are not enough. India's R&D spending is extremely low. And even when it is done, it is in public, most of it is in public labs, although share of private sector has been increasing, but concentrated in certain specific sectors, like as I mentioned in pharmaceuticals and so on. And geopolitical agility is key. The US-China rivalry opens doors for India, but it must proactively forge alliances and so on. And in fact, we have quite recently in the last few years tried to forge these alliances to secure technology and supply chains. And of course, I don't go into this aspect. And finally, the final reflection is industrial policy is back on the table. This book provides its continued relevance and necessity even in market-friendly economies. India's journey is a work in progress. It has achieved remarkable success in pockets, pharma, and software, but struggles to build deep self-reliant capabilities in strategic industries like electronics and clean energy, because we are late entrants here. Okay. And so there is a fair amount of path dependence there, in the sense that what you are doing now depends on what we have been doing yesterday. And since we are not doing much yesterday, to become a real manufacturer in so many of these industries becomes extremely difficult. The path forward requires a shift from fragmented incentive approach to a more strategic, coordinative, and performance-oriented model. And the goal would be to evolve from a high-tech assembler. So the high-tech leap that I'm talking is, by and large, we have become a good high-tech assembler, excepting for pharmaceuticals and software services. But a true global innovator and supplier is something that we need to move into. Okay, so that's, I think, and I thank you for your patience. I'm sorry that I took more time.
Thank you, Sunil. That was a masterly overview of the issues, the policies, and the prospects with a detailed, in-depth study of 6 key sectors. And I'll just echo your concluding statement that industrial policy is back, and probably the biggest sign of that is that the so-called Bretton Woods twins, World Bank and IMF, who for 40 years were discouraging developing countries from engaging in industrial policy, have come out with publications cautiously endorsing it in the last 1 year. In fact, just last month, the World Bank, 2 staff members have put out a study with a positive overview and classifying industrial policies into 14 different kinds, which can be implemented in different countries with different capabilities and for different sectors. As you have said, it has to be tailored to the needs of each sector. So let me now move on to the discussants. As I said at the beginning, we have the advantage of having discussants from 3 different backgrounds: science, science policy, and economics, which is what a topic like this deserves. We'll begin with Dr. Sabyasachi Saha, because he has indicated that he may have to leave early. So let me give him a brief introduction. By the way, I would request discussants to keep their comments to 8 or 10 minutes and leave us at least a few minutes for questions from the audience. I've already seen one question on the chat. Perhaps Professor Mani can look at that in advance and think of how to respond at the end of the discussion session. Dr. Sabyasachi Saha is Associate Professor at the Research and Information System for Developing Countries in New Delhi. For those of you who don't know, it is a think tank, an autonomous institution under the Ministry of External Affairs, which advises the ministry on trade relations and other economic policies. He specializes in innovation studies and international trade and industrial development with focus on developing countries. He is a resource person and expert on sustainable development goals and extensively contributes to international cooperation issues linked to G20, BRICS, etc. He has worked on several research projects and policy assignments for the Government of India and international organizations like UN and OECD. He has presented his work at prestigious universities and global forums, and notably he served as Think20 Working Group co-chair as part of G20 engagement during 2023-25. Dr. Shahab, could you please share your comments on Professor Mani's book and presentation?
Thank you, sir. Hope I'm audible. I'm facing some interruption sometime, but hopefully this should be all right. It's a real honor to join all of you, and apologies for the request to come in the beginning so that I don't have to leave if the call comes in between. So it's a great honor to be joining this discussion today, and luckily, when usually we purchase books for our library, there is, the book, the vendor comes with a lot of suggestions. And prior to the request, I never knew that I would be discussing this book, but we had already purchased. So I had a copy of this book when Dr. Bina asked me to kind of join this discussion. But it's a tall order for me to comment on Professor Mani's work and the extensive coverage that this book has brought in terms of the policy landscape, the nuances, the support from innovation studies literature and others, and where do we currently stand in terms of the industrial policy architecture. As everyone has noted, that industrial policy is being revisited from various angles, but currently the old understanding on industrial policy perhaps is going through a lot of changes. People do realize there are a host of failures. Mostly innovation scholars have been talking about failures beyond market failures, and mainstream economics need to take into account the challenges that we have been seeing over time, and how to devise and customize policies. India is in a particular spot at this point because we are a very large country, and the manufacturing sector is quite diverse. So from that perspective, I would just like to present a few slides, just 3 or 4, based on, because that is a complementary work that we have done in the recent past. So I'll just share a few slides to give you a bit of an idea. Okay, so this is a very recent paper that we have published in the EPW on industrialization and self-reliance. I just wanted to bring in some numbers. Of course, these are from the trade analysis perspective, and drawing upon the classification that we have from OECD or Eurostat. What we note is that India's exports of high technology products has increased almost over 5 times, from 10.66 billion USD in 2010 to 53.91 billion in 2024. So so exports have gone up over 5 times. During the same period, imports have gone up in this category 2.91 times, basically. But what we see is the period from 2020 to 2024 that India's exports of high technology products has more than doubled. during this period. So the recent pickup in the exports is something that we take note of, and of course, Professor Mani's book clearly lays down why the new industries are becoming very important in pushing India's high-tech exports. And we have also seen that the aerospace sector has recorded the fastest export growth. This is also a sector where FDI is important, value chains, etc. Not many studies are looking at how the spillovers are working out for this sector, but this is the factual part of it, that aerospace has recorded fastest export growth. And similarly, we see it for the electronic telecommunication sector as well. Next slide, please. So this is the overall trade balance when it comes to high technology sectors. So we have done the numbers for all the sectors, starting with the screen is not visible. Yeah, please. So we have done the numbers from aerospace to computer office machines, electronics, pharmacy, scientific instruments, electrical machinery, chemistry, non-electrical machinery, and armament. So we have done it for all these years from 2010 to 2024, both from the import as well as the export side. Next slide, please. Here, this is interesting because this is the composition of the sectors in exports and imports. So how it has changed between 2010 and 2024, and what is the relative position of these sectors in terms of value, both in exports as well as imports. And the right hand panel shows our dependence on countries. Basically, when we look at our export destinations, we are kind of overwhelmingly dependent on the United States, followed by other countries. And from the imports side, we are heavily dependent on China, and the second most important country comes it's quite low compared to China. So this is the nature of dependence we have, both on the export side as well as import. So that kind of defines our position currently, and the sectoral composition. The following slide, please. Here again, we have kind of disaggregated the numbers into our sources of imports, from which countries we are importing and for which industry, and then to which we are exporting, basically. So we have the current kind of the numbers on these in terms of how the export destinations might have changed over time, the importance of them, or the countries from where we source for particular industries, which has changed over time. So these are kind of numbers which can be referred to from the paper that we have done. And the final slide, please, if we have one more, I think. Or this is it. So this is something that I just wanted, because I don't have the time to go into the detail of it, but if we need to get the details of the trade numbers when it comes to the high technology sectors, the nature of dependence, the sectoral composition, the dynamics over time. So these are now available with us, which would be complementary to the work done by Professor Mani, and we can go into the specifics of the sectors and try to understand the innovation systems and the perspective. What I particularly like the remark that Professor Mani made about policy. Sectors are being policy enabled, but institutionally constrained, so which has a larger message, I would think, because at this point, through self-reliance policies, industrial, various kinds of incentives, etc., we are trying to kind of support the industry through policies, but there are institutional weaknesses which might kind of impede the nature of innovation that we might like to have across sectors. In the book, we see personally, I was aware of the details a bit on the pharma sector. Post-COVID, I've worked quite a bit on the vaccine industry. I had some knowledge of the EV sector, but seriously, I didn't have much knowledge about the wind turbine and the solar photovoltaics. So that gave me some new learning from it. Of course, on the vaccines, India's capabilities came handy when we had to scale up our production at the wake of COVID pandemic. Some interesting insights that I have acquired over time is, for example, when we were looking at the viral vector or inactivated virus vaccines that India kind of had the capabilities to scale up, etc. We also kind of had the capabilities and technology on the mRNA, because this has been going on for some time now. But what I was told during our work with scientists and industry is that the regulatory processes take time, because although the technology may be available, you need a lot of regulatory approvals before you can actually roll out some of these technologies. The landscape, of course, has got matured, I would think, over time. The regulatory architecture has also improved, but there were concerns regarding how we make the process more competitive when it comes to innovation. Now the vaccine industry has been looked at from various angles. Even the protagonists have written books, a movie has come out. So a lot of people have tried to understand how the ecosystem might work. But I would also try to think, now with government
So we lost him. So
Abhilashi, I think we have lost your connection. But anyway, I think we need to give time to the other two discussants.
Yes, sir.
So, yes, I think we'll just move on to the next two discussants. First, may I request Professor Sujit Bhattacharya to give his comments. Professor Bhattacharya is adjunct professor in the School for Sustainable Futures, Amrita University. He was formerly chief scientist and dean of policy research at one of the CSIR institutions called NISPRA. He was a professor at the Academy of Scientific and Innovative Research and at JNU. He's on the boards of Asian Society for Innovation and Policy, International Society for Scientometrics and Informetrics. He's the founding editor-in-chief of the Journal of Scientometric Research. He has published extensively and presented in events like the 78th UN General Assembly Science Summit and the Global Ministerial Forum. So he brings to this discussion very deep knowledge of the scientific background to innovation. Professor Bhattacharya, over to you.
thank you so much for this warm invitation and the introduction. It is indeed an honor to be part of this discussion of one of the leading scholars in innovation studies, Professor Mani. And in fact, a few years back, we had also the privilege of having the book review of his book co-edited, The Rise to Market Leadership, in our journal itself. And of course, to ISID, who has this very, I would say, engaging program in itself to bring the discussions, to bring a sort of intellectual platform across the country and globally. And I always admire the way it shapes up the discussion forward. And for that, it is great to be here today. Recently, in fact, it is also an important take that I do not come within that, what you call that economic scholar as such. I have a wide interdisciplinary, what you call, take. I come from a strong science background of physics, and then I moved across over the years into science, technology, innovation policy, science, technology, ecosystems, and all that. And that helps me to, in a sense, try to look at it from the other lens also. And at the same time, I am also cautious about the fallacy of that. But then the interesting, engaging discussions make you what you call learning all the time. So recently, we had the three important work which we did with Niti Aayog, and I was a co-author of that. And in fact, you can get the book also. They are the Pathways to Progress, Analysis and Insights into India's Innovation Story. And that why I'm mentioning that is that, and parallel to that, we had these two work which we did, again, co-authored with them. Ease of doing research and development in India. And parallel to that, a survey report on ease of doing R&D in India. In fact, these reports also formed the, what you call the, a substantial portion of the high-level committee report which went to the government, and we hope that something will come up from that. So what I see is that it is a very, very timely intervention by one of the leading scholars to bring this book in itself, and so well titled and so well framed. And but only the part was that, unlike Subhasachi, I did not have the privilege of actually going through the book. And Dr. Bina was very kind enough to share the chapter 1 and part of it. And so I went through that. And my only point, which I don't know how it works out, but the only point is that maybe it would be a good idea to also have a book which can be purchased at our individual end also. So with that, but I will surely try to see that how in my connecting libraries I will get this book. So Professor Mani, what I want to do is I want to begin from where you ended, your concluding slide, because I think it can be the most productive starting point for discussion. You offer very important 4 conclusions. Industrial policy is back. India's journey is a work in progress. The path forward requires a shift from fragmented incentive-based approaches to strategic, coordinated, performance-oriented governance. And the goal is to evolve from high-tech assembler to global innovation and supplier. And in fact, these are something which you have spelled it so articulately, succinctly, and this is what really no one, any of these scholars and any of them across would say that these are the things which, you can do it right, we can really come back and make this, what the main thing which you are trying to say is that the technological leap forward. But drawing from that, I see that the book makes it very lightly so that the book provides that industrial policy is back. It's a very good title in itself, and it tries to actually trace it to that extent, that why we are making that argument so well framed. But one thing which was also, I thought that would be interesting to look at, in a sense, to engage with the failure cases also. Maybe that how within that 6 sectors, where although so failure happens within that, where we learn back and try to look at, and where we actually framed our policies and all that, and where actually we could not do at all. So this would be also an interesting take on your the case studies, which I would just say that because I have not read the full view, maybe within that wrapping up within that chapters, you have also placed it across. Another thing which we have also strongly said that in our that pathways to progress also, the leapfrogging is important, but ecosystem depth to sustain a leap is also very important. That how we develop that ecosystem and how we can do this type of a leap, if we are trying to say that. So what I feel is that industrial policy without equivalent investment in upstream capability, in the research institution, the human capital pipeline, the university, industry knowledge flows that convert incentives into genuine technological capability, will produce activity without knowledge accumulation, and it will build assemblers, not innovators, which you are trying to put it very nicely in the end, that we need to be innovators in a sense. And this whole part of this, which I will come to that within that time frame, that where we look at it and where we find that again connecting is that STI ecosystem connect to that product economy, manufacturing economy, and that is where we also try to dive deep to looking at all the different schemes within the government, try to characterize those schemes, and then try to actually put that schemes into that what they do and what they do not do to make this what you call that roadmap and all that. But we felt also within that what Saji was trying to say is that there is the inherent structural challenges in itself within our institutions which actually prompted us to look at across the whole country 8 major workshops, and where we had 541 or so persons from across the universities, from the DIS and all, to get that evidence for where this ecosystem, building up this ecosystem, where are the structural constraints in itself that is happening. So with that, I would say that in a sense, when you look at comes to the mind of China in itself, that how China's solar dominance was not built at incentivizing module assembly as such. It was built over 2 decades of looking at polysilicon chemistry, crystal growth equipment, cell process engineering. But we also had that many bits and pieces of research support system, but that integrated support system with a reflexive pathways and pathways which would be there, and then strategically choosing which actually would be one thing which I would see, that how the industrial policy would help to develop this whole, is because we are talking of a knowledge intensive industries, that how they develop this ecosystem in itself. And then I will come back to that at a particular PLI scheme itself, which I find that bit an initiative, because I will not stick to other schemes, but that will be too long, but I will just focus on the PLI scheme itself to draw some of the attention in that. India's journey is a work in progress, the second point which I've raised, and it is really the point which I've tried to actually make a very important arguments also. And I also believe that this India's journey is a work in progress, need to look at various different layers of how the work in progress is, and I am sure your work has looked at it. But also there are 2 points which I would like to say within this short time, is that when we are saying that it has remarkable success, say in pharma, we also have to bring the different qualifiers in a sense. And these different qualifiers, say, if you look at abbreviated new drug application, it is a remarkable instrument of imitative excellence, I would say. To file a successful NDA, you must demonstrate your process innovation, a bioequivalent product to the origination at a fraction of the cost, genuine scientific capability. But then we at the capability which is there at the volume end of the pharmaceutical value chain. It is yet success at the other end of new drug applications, where I find that there can be a different ways to look at it. Look at the clinical trials, which is now possible to look at. And we have looked it also through the Dimension database and other, and try to see that how we are positioning ourselves also on that front in itself. So, and then the story also shapes up in certain different ways. The metrics being used itself, the patent count, export volumes, AND filings, PLI, are all output measures, I would say. They tell you what was produced. They do not tell you what the underlying knowledge base deepened to that extent, I would say. But because the more problem is that the Goddard's law, which I will say, what it does is that the measure becomes the target and ceases to be a good measure in itself. And that is where all these indicators, when we look at indicators, that the underlying capability that the indicators were originally meant to track does not actually end up tracking that. And it ceases to be a good measure of that. So we have to be a bit cautious when we are looking at the indicators with the different caveats. And you have also tried to point it out at the end of your presentation and in between. So again, harping back that the investment in upstream capability without removing the obstacles, which we try to look at in our ease of doing research, present researchers from actually not doing the research that will build the capability. And that is a long story and a whole study in itself that which is not time to actually discuss here. The upstream AI dependence on China itself is a proof of that how, but here I would say, I will come back on this to say quickly, and I will not take much point, keeping in view the time constraint. The path forward requires a shift from the fragmented incentive-based approaches to strategic coordinating performance-oriented governance. And this is exactly the point which actually made us look at that what is this whole fragmentation it was all about, and how actually this type of fragmentation would we can look, and our looking at the fragmentation was based on the different schemes and how the different talking to the different ministries and all that, and then not really believing in a sense what they are saying on Toto, but going back, looking into these schemes and all that. And I see that this fragmentation is everywhere, not only here. The fragmentation which talks of a new form of governance, new forms of institutions, new types of intermediary organizations in itself. And then the other part, when we looked at that our innovation model in itself, and we tried to look at the technology readiness level, where we had created that one of the influencers in the country, I would say, on looking at this technology readiness level and creating an organization, Netra, where we are trying to validate these technologies and other aspects. We see that India has a very closed innovation model in itself, and where the knowledge flows are so weak, and that open innovation and all that concept which you say looks into the practice of this not happening at all. And at a particular level itself, there are so many constraints, not only the funding constraints, there's also constraints of networking and all those things which we have learned in innovation studies and all that. They come into actual primary evidence of it. So this is a very interesting part in itself which you have actually touched upon. Another thing that which I would I was very happy to see that the way you were looking at the technologies, how the technologies are growing, and understand looking at the black box of technology, which is you are among a few economists I see that looking into the black box, and touches me also in a sense that I connect to your work very well in that sense. But I would say that also the strategy has to be built on that, say, if you look at this solar photovoltaic cell, what is this strategy within which we enter that. We should not be locked in into a by using the PLI scheme, locked in into the output type of production of a technology which is, but we should be, I would say that the time is less to say that, but but the disturbing noise about our PLI, in spite of many of a new incentive, is that if I will again go back to your US model, that if you look at it, that United States did not pass a CHIPS Act, it passed a Chips and Science Act. The conjunction is deliberate and consequential, and the money was split exactly between the semiconductor manufacturing and the foundation of scientific research, fundamental. So the PLI, what I see is that no equivalent investment that is very strongly connected with the science companion, in a sense, that how we look at creating that knowledge capacity, which is so very important to as we move forward. So, and just recently looking at many of the things, when you look at the pharmaceutical and the other itself, the dimension, which I was just reading Dinesh's work on talking of the quality of our pharmaceutical products and all that regulatory aspects. And the other things also, it talks of actually we are at a very inflection point, I would say, is that, but there are many promises, many things which are happening, but putting it all together, which you have tried to do, is that is very interesting, very important, and I look forward to reading this whole book. But at the same time, I would say that with a cautionary note, that rather than emulate the Silicon Valley, India must develop its own approach, one that reflects its unique economic structure, demographic realities, and the development priorities. And that is why your book will provide new insights and pathways, because we have to look at how not only this technology leap, how the reskilling and upskilling will be done, what is the job market that will be affected, how the new jobs can be we create that. So all the different dimensions of this leap, which has to be seen across, and I'm sure that many of these aspects you have drawn attention to, and some of these things which you have already highlighted. And with that, I think I conclude. And so thank you so much for this opportunity.
Thank you. Before we move to our last discussant, Dr. Shah has come back after he lost the connection, and he has requested about 1 minute just to complete his comments. And the organizers tell me that we are not bound to finish at 5 o'clock, which we have exceeded. So if Dr. Shah can quickly complete his remarks, we'll move to our last discussant.
No, thank you. Sorry for the interruption. This the work that
We are losing you again.
I was sitting on the vaccine required. So you have the political. There is a problem.
Yes, your voice is
Is there a
breaking.
problem? Am I audible? Oh, okay. Then let me skip. I won't waste time on this. But mostly just to without giving any sort of comment on the book. But what I find remarkable about in the chapter on vaccines, and also in the chapter on EV, the kind of granular focus that he has brought in terms of looking at the vaccine supply chains, because supply chains are also critical to the success of industry, and increasingly we are realizing that. And even within the vaccine supply chain, several intermediate inputs may not be high tech, you know. In that sense, it comes from various HS chapters, but unless you could ensure the availability of would not succeed. And definitely for the readiness levels across various technologies are quite different. He has presented a important table in the book in terms of where we stand on various components, various technologies that go into energy storage and others. So I stop. I think there is some problem. Maybe I'll also send my comments to Professor Mani in writing. Yeah.
Yes, I think that would be a good idea. I think we got the gist of your remarks. Our final discussant, who has been waiting patiently, is Dr. Sharadendu Bhaduri, who is currently an associate professor with the Center for Studies in Science Policy, School of Social Sciences, Jawaharlal Nehru University. His work focuses on frugal and grassroots innovations, technological capability, and technology policy. He has authored several publications in the area of innovation. He was Prince Claus Chair Professor in Frugal Innovation, Development and Equity at the International Institute of Social Studies of Erasmus University in Rotterdam in the Netherlands. So, Dr. Bhaduri, over to you.
Thank you, Professor Bhattacharya. Am I audible and without any noise? Because there is also an air conditioner running in my background, and it's not very up-to-date machine, although high-tech, but a bit dated technology, making it difficult maybe at times to follow what I am saying, or is it all right?
No, you're very clear and we cannot hear
Okay.
you.
Okay. Thanks for that. If I could get the permission to share PPT, Professor Veena.
Sir, it's allowed, sir.
Oh, it's allowed? Oh, okay, thank you. No, it's disabled, it says.
Please try again, sir.
Yeah, okay. Yes. No, okay, yeah, this is the one. Now, of course, I join others in congratulating Professor Mani for coming out with this very comprehensive analysis and of course sharing its my extreme privilege to be a discussant of the book at this juncture. Unfortunately, my reading or my analysis or my observations are also without having seen the book. So I would, what I plan to do is to try and extend the debate a bit further and see, how some of the core ideas that Professor Mani has so nicely and so, justifiably flagged can be taken further. Or subject to some more critical discussions. So for the last few years, I have been spending more of my time and energy into studying frugal grassroots innovations. So please bear with me if I somehow transgress the boundaries of our normal understanding of innovation and get into discussions of something like Jugaad, which is often seen as outrageous among in the innovation narrative. Why I do so? Because I find that Professor Mani and we have a shared set of initial conditions and concerns. By initial conditions, I mean that Professor Mani has also wanted to position his argument in the context of the financial crisis and the pandemic. And some of the research that we have been doing on frugal innovation have also been positioned in a very similar manner. The second is about his concern to see whether one size fits all approach works in the context of innovation, which I also share. And the second motivation to try and extend this argument comes from a 50-year-old observation on the so-called cognitive framework of innovation economics, which was highlighted by Nathan Rosenberg in his book called The Perspectives on Technology. In that book, what he writes is something that may, just a minute. Yeah, okay. May be important in this regard when we want to extend the argument. In his analysis, economists, he argued, they typically reveal a hierarchical conceptualization of different forms of knowledge, quite similar to that of the natural scientist. That is to say, they attach the greatest importance to pure forms of knowledge, that is scientific knowledge, and hold mere technological or engineering knowledge in low esteem, and show little interest in the manner in which such knowledge is generated or diffused. Now, for him, it's a problem because this pushes below the radar many, in his words, inconspicuous and unspectacular efforts continuously undertaken to shape and reshape the boundaries of economically useful knowledge. Now, what is important for innovation at the end of the day is that people should find it useful. And I am basically restricting myself to that kind of an understanding of innovation, irrespective of the fact how much it sort of advances the frontier of scientific knowledge. And he sort of, follows up with this argument. And in 1988, he comes up with a very interesting, provocatively titled paper. I think it's one of the most cited paper for me. I mean, in most of my papers, I have tried to link my argument with some of the arguments given in this paper. And the title of the paper was "Why Americans Are Such Poor Imitators." Now, this sort of turns the argument on its head, which had economists for a long time tried to maintain by giving innovation and imitation sort of a two different pedestal in terms of knowledge hierarchy. So one of the main conclusions that he draws upon this paper, and the book that I think we can mention here is a book by the recent Nobel laureate Joel Mokyr, talking about the historical origins of the knowledge economy. So from both the authors, one of the main conclusions that comes is the interaction between different forms of knowledge. So for Rosenberg, in case of understanding Japan's growth and US's limitation, it is the lack of interaction in USA and more interaction in Japan among the producer, user, and the R&D. And for Mokyr, it is about propositional knowledge and prescriptive knowledge. I mean, roughly speaking, they can be categorized as, the theoretical knowledge and empirical or practical knowledge. So what for Mokyr stood out as an exceptional phenomena which contributed to the Industrial Revolution in Great Britain was they could allow the interaction between different forms of knowledge, the scientist's knowledge and the practitioner's knowledge, much better than other countries. Otherwise, France had better inventive capacity, but they could not make use of that inventive capacity to become a leading innovator in the time of the Industrial Revolution. And we have used some of these arguments to also critically look at Europe's failure, despite having, a very sophisticated health infrastructure, to deal with the pandemic, the COVID-19 pandemic. In a blog so far, in that my colleague Peter Noringa and we tried to argue that it was Europe's over-reliance on institutional separation of knowledge and over-protocolization that had prevented them from bringing together different kinds of expertise at the time of crisis. Now, this is the kind of a background that I have to offer. And the rest of the thing is about two case studies based on the research that we have done. Both are presumably from the high-tech sector, but both might also give a critical understanding of the way we are trying to look at, policy space homogenization and the question of self-reliance. So this Akash missile system, if you go back to the newspaper of the Operation Sindoor days, you would see that the missile system has been widely appreciated for its precision. And the Brazil wanted to purchase this technology and so on and so forth. Now its development saga is very different. It was initiated in 1983. Now, from 1983 to 2013, it was a constant tussle between the DRDO, the Air Force, and the Army, where DRDO was pushing the Air Force and the Army to induct it into their system, use it, and develop user-based data to make more precision. The Air Force and the Army were instead more interested in sort of trying to always look for a zero-error technology or a more precise technology that was available elsewhere. So there was this constant pull and push, which led to its delay in induction into the Air Force and the Army. And finally, after repeated trials, after repeated rejection, it got inducted in 2013. Now, the rest of the story is in its success in Operation Sindoor. And I'll come back to round up the main conclusion that I draw from there. The second one is about what I call, maybe someone in the innovation studies might find outrageous, to include Jugaad in the domain of high tech. But I was motivated by one of the initial points in Professor Mani's presentation, or the slides that I had read, that he also points out that the beginning of the electric vehicles industry in India started with two-wheelers and three-wheelers. So I thought maybe I can safely talk about what had happened in case of the three-wheeler that one has seen around us. So the story starts with a CSIR-backed solar-powered paratransit vehicle, which they named as Solekshaw, and it got a very wide coverage in the Times in the manner that I have quoted here. That Solekshaw, a solar-powered rickshaw, provide a breath of fresh air. And this was actually done by the CIMERI CSIR laboratory. But the fact is that despite the strong scientific and technological backing, Solekshaw failed. What happened, however, is not less extraordinary. The Indian paratransit space quietly underwent a transformative shift with the emergence of e-rickshaw. An electric paratransit vehicle evolved in a bottom-up manner without any support from the mainstream institutions of science and technology. Now, it was adapted and manufactured in small and what we call obscure sites scattered across the city of Delhi. Colloquially, a jugaad eventually triumphed over the product of the organized and protocolized science. And to sort of give its due as legitimate innovation, this is something for which there are multiple producers today, and it is used by over 60 million passengers every day. Now, what do we make out of these examples? And that is my last slide. Of course, we have been talking about, the need for having more R&D, need for having more technological basic research. But if we consider innovation as something which finally has to serve the people, then what has not been paid attention to in the policy making so far, in my understanding, is how to coordinate between different forms of knowledge. So in case of the Akash missile, And in case of the electronic vehicles, it is the knowledge interaction between user, producer, and innovator which would lead to an effective feedback for an incremental adoption of a technology was not something which the policy making infrastructure appreciates. I mean, we all try to have a solution at one go, and it has not worked in the case of technology in many ways. And some of these examples of our studies probably show that. When we talk about regulation of a technology, we are mostly focused on the, trying to regulate its final product. And if it does not meet the standards, we try to penalize the producer. Whereas in many such innovations, it is possible that, what we call responsive regulation, that is like a more multiple, multi-centered regulatory framework, multi-actor regulatory framework, in more line with, the restorative justice that might promote innovations in many ways, even in the high-tech industry. Now, the two lessons that I draw from these two is, for how long we can ignore the actors who could be important, but they remained below the radar of the formal innovation systems, be it in the electronic vehicle, electrical vehicle, or maybe even in the digital, sectors, where there are interesting individuals, freelance actors who might come and contribute meaningfully into an innovation process. And the final point that I would like to make here, it talks about a very different approach to the self-reliance models of innovation. I mean, first of all, I would have my reservation to talk about a completely self-reliant model of innovation, partly because this, what we discussed in these slides, the useful knowledge comes from multiple sources, and any form of self-reliant or an autarkic model of self-reliant would close down a few of those avenues and might hamper innovation and productivity in the long run. Secondly, however, what the pandemic has shown us that the supply chain bottlenecks might be in jeopardy even at the national level. So the question of local economy, question of subnational self-reliance may be also something that we must pay attention to. And the ideas and the debates of self-reliance should not be restricted to the national boundaries of a country. I stop here, but thanks again for giving me this opportunity to engage with the conversation and a very extensive exercise by Professor Mani. Thank you so much.
Thank you, Dr. Bhaduri. That was a refreshingly different perspective from the grassroots up rather than the top-down view that most technology policies adopt. Well, we are long out of time, but I think I'll invite the speaker, Professor Mani, to respond to the two questions which were on the chat during his presentation itself. And then we'll see if maybe one or two more questions can be entertained from the remaining online audience. One question which came in was from Charulika Sharma, a PhD scholar at Indian Institute of Foreign Trade. She asks, I understand the rationale for comparing India with the United States in the context of high-tech industries. However, I would like to inquire whether a similar comparison can be extended to low-tech, medium low-tech, or medium high-tech industries. These are standard terms to classify different kinds of technological sophistication. Actually, Professor Mani only used this direct comparison in the case of the COVID vaccine, not for all his 6 case studies, but Sunil, would you like to respond to the general point?
No, first of all, I thank everyone for their comments. And I think you have answered, Professor Aditya, you have already answered this point. My comparison of India and the US was only in the context of COVID-19 vaccines, because, and that was done because there are only about 8 or 9 vaccines that was allowed to be, even reach the stage of emergency user authorization, worldwide. And I'm referring to the 2021 to 22 period. At that time, there were only 8 or 9. And the most successful among them was actually the US, the mRNA-based vaccine of Pfizer, BioNTech, and Moderna. And then from, of course, India, we have a few other vaccines. So the comparison was only done, as Dr. Banerjee, Aditya Bhattacharya also said, it is only in the context of vaccines, not in other industries.
Right.
And,
The other
and I've
question
also
that
explained the reason for why I've chosen the US, and
Yes.
because I anticipated that question, and given
the other question that came was from Professor Dinesh Abrol, a former faculty member at ISID itself. He asks, if I go by the argument of Sabyasachi on nature of dependence on imports for high tech, we are doing well. What is Sunil's view? Dr.
Yes.
Sabyasachi gave different tables of
Yeah.
imports and exports.
Yeah. Actually, in my, let me also respond to the first point about Dr. Saha, where he has mentioned that trade in high-tech products needs to be taken into account. It is actually in almost every chapter of my book, I have the trade issue, how much is exported and imported. But the point is, overall, the share of high-tech exports in India's manufactured exports have increased to almost like from virtually nothing to 12% for the most recent period. But the import content of these exports are very high. Okay, so I suppose that's what Dr. Abrol is also trying to say. And in fact, a majority of the high-tech industries, excepting for pharmaceuticals and software services, our trade surplus is there's no trade surplus. It's also it's actually a huge trade deficit. And in fact, we even have say for instance, solar photovoltaics. We did not even have a proper HSN classification for solar photovoltaics, so that you can actually measure. And in fact, you can see that the Press Information Bureau of India has come out quite recently with because they wanted to know, with all these incentives going, are we still highly import dependent? And so, because earlier they were having an aggregate category, and so that didn't show much imports. But when they actually took all the cells out of that aggregate category, as I said, polysilicon cells and then modules. Okay, so if you take the cells and polysilicon out of the aggregate category, the import dependence was very high. Okay, so so that's a point. So every high-tech product other than pharmaceuticals, and in pharmaceuticals also the active pharmaceutical ingredients are still import dependent. Of course, the government is trying to reduce that. So we are quite import dependent on almost everything. And this import dependence has increased as we proceed, and even some of the new industries which we are actually setting up. The new industry is semiconductor industry. There also, if you look at like electric vehicles, the silicon carbide is what we require, and that is only quite recently we have started. At least a foundation stone has been laid for a factory. So I think our import dependence is extremely high, and all these high-tech industries will remain import dependent. And the difficulty of reducing the import dependence is that a lot of the components which are imported are covered by a wide range of patents. And so if you do not have the intellectual property right for domestically manufacturing them, we have to be, based on licensing of this production here. Again, import dependent. So simultaneously, if you look at the technology trade balance of the country, that has also been increasing quite rapidly, And in fact, I've tried to show that also, in the book as well as in other papers, where the technology trade balance has also been increasing very rapidly, which is the difference between payments that we are making for intellectual property, various kinds of intellectual property rights, and the receipts that we receive on the basis of, and most of our receipts are in the form of copyrights from Bollywood movies, so these are not hardcore technologies that we are talking about. So our technology trade balance is quite high. So our import dependence is very high at all. And in fact, my guess is that we will remain like this for some more time.
Remains
because of the path dependence of the technology. You can't enter when things the upstream industries are covered by patents.
Yeah, exactly. Well, we are almost hitting 5:30, which is half an hour overtime. So I don't think there's scope for inviting more comments from the audience. But I'd like to give Professor Mani an opportunity to respond to any of the discussants' comments in case he feels that maybe they did not fully understand what he was saying, or whether he is inspired to extend or modify any of his analysis.
No, I think I enjoyed listening to the discussions, and I think most of them are actually complementary to what I'm saying,
Yeah,
additional
exactly.
extensions
That's what
and
I
so
thought.
on. And the accepting the point which Professor Bhaduri has made, and so even if you take the e-rickshaw, for instance, you won't be able to run the e-rickshaw on the road if you don't have a battery. And the battery technology is because that is the key. That is the key thing. The other things that you talk about is basically design of the. So that even in my matrix that I didn't have much time to present, we are quite capable in for instance wiring and those kind of things and basic structure and so on. We are quite capable, but these are not important. The important key technology is basically batteries and the silicon carbide wafers for power electronics, because that is used for charging as well. And because these are the two key technologies there. So there we are completely dependent and on hard science. So even in what I'm trying to say is that when the frugal technologies are very important, but there also you require a fair amount of hard science, which then will have to be, as you said, the other type of knowledge to be made more practical. So wind turbines, you find the manufacturers have been able to localize the technology, because we are characterized by very low wind speeds. So if you have these blades turbines, imported from abroad and put on our hills and valleys, they will not generate much electricity. And so they have to be, so there are some local value addition has been done, but there again you have to understand the science of composites and so on. So science is very much behind even in a lot of the frugal technologies.
Exactly. Well, with that, we come to the end of today's very informative and interesting session. I would like to thank Professor Mani and all the three discussants for sharing their views, which, as Professor Mani said, were quite complementary to each other and gave us a very holistic picture of the complexities of developing high-tech industries in India with some mix of basic science, adaptation, and implementation. And I think we will all take with us some insights for how we think about the, and please watch out for future
Thank you.
workshops hosted by ISID.